Alright, so today we need to form three different conics which pass through the point -2, 3 and another point 4 units away. So if I first plot -2, 3, that's going to take me here. And then another unit 4 units away, which you can go up, down, left or right, doesn't really matter. In this case, I think I'm going to go to the left, 1, 2, 3, 4. So my second point here will be -6, 3. Now, for any of my conics, it's really important I know where the center is. So the center of a conic, which is going to pass through these 2 points, is going to be right here in the middle at -4, 3. So that point's quite important. Not really worried about these at the moment, because that's going to determine what our h, k, and r values are. If I am, say, starting with a circle, I need to know h, k, and r. So to get to that center of -4, 3, my h value is going to be -4, my k value is going to be 3, and my r value, so that I get from the center and past those 2 points that I'm interested in, is going to be 2. So for Cartesian, I can piece that all together, and I'm going to get x plus 4 squared plus y minus 3 squared is equal to 2 squared. For parametric, I'm going to have x is equal to 2 cosine of t minus 4, and y is equal to 2 sine of t plus 3. Then I can go ahead and draw my conic. Remember, if I'm doing a circle, the radius will take me 2 up and 2 down. So my circle should look something like this. Oh, that last one was a bit wonky. Not too bad. Then when we move on to the ellipse, we're not interested so much in an r value anymore, but our horizontal distance is still important, but we're going to call that a, and b is our vertical distance now. And I can pick any number that I want. It doesn't really matter as long as it's not 2, so I might just pick 1 in this case. My Cartesian equation actually is very similar, but instead of having r squared at the end, I'm just going to have it equal to 1, and that's just the equation is always equal to 1, and then my first part will be over the a value squared, so over 2 squared, and my b value will be over 1 squared, which is just 1, but I'm going to write it as 1 squared, just so I remember that's how the formula is. And the only difference to the parametric equations is that in the y section here, because this is my vertical distance has changed, it's going to be 1 sine instead. You don't actually have to write the 1 because 1 times sine is still just sine, but again, you can just put it there to help you remember. And then so when I'm drawing my conic, I'm only going 1 up and 1 down now. And so I connect these points. Not too bad. And you want to make it look like an ellipse. Then for the last one, the hyperbola, again, we're only changing a little bit at a time. The hyperbola has the same h, k, and a and b values. You can just keep them all the same. The only difference in the Cartesian equation is that it's now minus in the middle. And the difference in the parametric equation is that instead of cosine and sine, we're going to be using secant and tan. Now, when we're constructing our hyperbola, we need to make a box in the same extremes that the ellipse had. Then, once you've got that box, you need to connect up the corners of it using a ruler, of course. And these create our asymptotes. So asymptotes are kind of like boundary lines. I can't go outside them. So your hyperbola needs to start at the point that it's going through and head out towards the asymptote, but never touching it, and the same on the other side. So the hyperbola itself is actually just the green line in this case, and all the other lines sort of help us with construction. And that's it. So we had 3 different conics drawn,